In the last video, I caged an AI agent with bubble wrap, and the real point wasn't the tool. It was that you can cage an agent in a lot of different ways. The cage is just a set of moves you build from whatever you've got. So this time, let's do it with the agent most of you actually have at work. GitHub Copilot's command line agent, the harness that runs the model and carries out whatever it decides to do. Now, here's the timely part. Just this week, GitHub shipped a sandbox of its own one command, and the agent's shell is boxed in. That's genuinely good, but it's one wall, it's off until someone turns it on, and it only covers where commands run. The agent still picks its own brain, reaches its own tools, loads its own skills, and spends your money, and a sandbox touches none of that. So we're going to build all 5 walls. Where it runs, which brain it uses, which tools it can reach, which skills it loads, and what it's allowed to spend, all free, all on the tool you already pay for. And at the end, we fold them into a single command, so caging the agent is just how you start it. Let's cage it. So wall 1 where it runs. Off your machine, this thing runs as you. Your keys, your cloud logins, your whole home folder, anything you can touch, it can touch. The quickest fix is the one GitHub just gave us inside a session. You turn on the built-in sandbox, and the agent's shell commands get walled off from your files, your network, and your system. If that's all you ever do, you're already better off, so do it. But it only fences the shell, it's off by default, and it still sits on your real machine. So when we want a harder line, we give the agent a box of its own. It's 3 commands, and it's free. We install Podman and start it up. That's the sandbox it runs in, no admin rights needed. Then we start the agent inside that box with 3 deliberate choices: an empty, throwaway home folder, so there are no keys or credentials lying around to find. Our project mounted so it can see the code and poke around, but it physically can't change the originals, and every capability dropped. So even if something slips, there's nothing there to grab. Now we run the scary test. Point that same agent straight at our secrets and tell it to go find them. And it comes back with empty hands. There's just nothing in the room to take. Now you're probably thinking, if it can only look, it's useless to me. Fair enough. So here's the thing. It never touches your real code. It works on a copy, hands you back a diff, and you're the one who applies it. The agent proposes, you commit. We didn't cage the work. We just put you back in the chair as the person who actually presses merge. Every prompt this thing makes has to be thought about by a model somewhere. At work, that's your company's approved model up in the cloud, under a contract that says your code isn't stored and isn't used for training. And that's completely fine. The one thing we really want to avoid is some model nobody's vetting at all. So on your own machine, we go one step further, we run the brain ourselves. It's about 4 lines. First, we load a small model in LM Studio, and we give it a big enough context window, because the agent's own instructions are enormous, and we don't want to starve it. Then we start its little server on our own network. Now we tell Copilot to talk to that address instead. We hand it the key and the model name, and we flip it into offline mode, so nothing quietly phones home. We run it, and it just answers, locally for free, no sign-in. The brain we couldn't see before is now one we actually own. Every connector you bolt on is a new door this thing can walk through, so naturally we want a guest list, only the tools we approve. But here's the catch, and it's an important one, that allowlist is just a file sitting on your machine. Whoever controls the machine can edit it, so on its own, it doesn't really control anything. What makes a list actually mean something is what's standing behind it. And we already built that back in wall 1 inside the box. The only connectors that even exist are the ones we installed. And the only places it can reach are the ones we allowed. So the list gets its teeth from the box, not from the file. Adding a connector itself is just one command. Now, at work there's a stronger version of this. An administrator publishes an approved list up on the server, tied to your sign-in, so neither you nor the agent can quietly edit it away. That's the part you can't really fake on a laptop. It needs the company behind it. So offline, the box is doing the enforcing, signed in at work, the registry is. Same goal, just two different muscles. A guest list tells you who's allowed in. It tells you nothing about what they get up to once they're inside. And remember, a skill is really just instructions. And instructions can tell the agent to go use a tool. Here's the nice part: the command line tool is the harness, which means every single tool call has to pass through it. So that's exactly where we put a camera. We drop one small file into the agent's hooks folder, and it fires before any tool actually runs. It hands our little script the call and its arguments, and our script gets to decide: log it, wave it through, or shut it down on the spot. So if it wants to open a file, fine, go ahead. If it suddenly wants to phone out with your SH key, that's denied before it ever leaves the machine. And it doesn't matter who asked. The model, a skill, or some stranger who slipped a line into your prompt. Same call, same camera, every time. Skills drop in from public marketplaces, and the agent will happily pick them up on its own. But anyone can publish to those marketplaces, which really means anyone can publish straight to your agent. So we stop shopping in the open store, and we stock one shelf ourselves. It's two commands. We add our own private catalog as the source, and then we install only the skills we've actually looked at and trust. Now the agent's whole skill set is a short list with our signature on it. Nothing loads that we didn't deliberately put there. There's one thing left, and it shows up on the invoice. An agent stuck in a loop doesn't get tired. It just keeps spending, and usually nobody's watching the meter until it's too late. So we put a meter on the thinking itself. We stand a little gateway in front of the model. It's called LiteLLM, and we give it a small database so it can keep score. Then we mint a key with a hard cap on it, just a couple of cents, and we route Copilot through that gateway instead of straight to the model. Now every single request gets counted against the cap, so we deliberately send it into a loop and watch the spend climb. And the moment it crosses the line, the gateway just refuses the next call. The agent doesn't get to decide to stop. It asks for one more thought, and it gets a closed door. So that's 5 walls. But 5 separate steps you have to remember is 4 too many. A control you have to turn on is one you'll forget. So we do the obvious thing: we make the cage the start command. We write one small launcher that brings up the box, points the agent at the brain we chose, drops in the camera, applies our guest list, and routes everything through the meter, and then hands us the agent, already sitting inside all of it. From now on, you don't run Copilot and then secure it. The thing you type to start it is the cage. At work, your company can pin this at the device level so nobody can skip it at home. This little script is your version of the same idea. Make the safe path the only path. Starting your agent and caging your agent become the exact same move. Now, none of this makes the agent safe, and I want to be straight about that. The box still sits on the same machine underneath. It shrinks the blast radius. It doesn't erase it. The meter is blunt. It'll happily kill a perfectly good job mid-thought just as fast as a runaway one. These are walls, not magic, but that was never really the point. The point is that every wall you put up means there's less the agent can wreck if it slips. And honestly, these aren't 5 tools, they're 5 capabilities. Whatever agent you end up running, get these 5 in place, and the blast radius gets smaller. And here's why this holds whether you're one developer at home or a whole bank. Everything you just watched ran free on a laptop, completely offline. At work, the model just sits in the company's cloud instead, behind that registry and that contract. Same wiring, the address changes, the stakes change. The box, the guest list, the camera, the meter, they're the exact same moves, whichever agent you're caging. Which means you finally get to do the thing you actually bought the tool for, let the agent off the leash and genuinely move fast, without lying awake about it. That blunt meter we just ended on. Next time, we make it smart. A kill switch that actually watches how the agent is spending and steps in before the damage, not after. I'm Stig. I help build and secure the systems behind a group of Danish banks. The kind of place where the agent spent how much is not a sentence you survive. These 5 walls are exactly the concerns I help teams work through before they ever let an agent loose. The whole build, every command, every file, is in the repo linked below. Go fork it and cage your own agent tonight. See you in the next one.